Hello everyone, welcome to Physics Facilitator. So in today's session we are going to start a new lesson, that is motion. So we are very familiar with this word motion, right? ఎక్కడెక్కడ మనం ఈ మోషన్ వర్డ్ ని యూస్ చేస్తాం, or in which situations or in which places we use this word generally, where we find something is moving or some object or some body is moving from one place to another, we say that body is in motion, right? So if you say a car is at position A and it want to reach to position B, ఇక్కడ ఏమవుతుంది, కార్ ఈజ్ ఎట్ పొజిషన్ ఏ అండ్ అది ఎక్కడికి వెళ్ళాలనుకుంటుంది, బి పొజిషన్ కి వెళ్ళాలనుకుంటుంది. వైల్ ట్రావెలింగ్ ఫ్రమ్ పొజిషన్ ఏ టు పొజిషన్ బి ఇట్ విల్ టేక్ సమ్ టైమ్, రైట్? అంటే ద కార్ ఈజ్ మూవింగ్ ఫ్రమ్ పాయింట్ ఏ టు బి with respect to time or within a time period, then that car is said to be in motion. Okay, for this we can give many examples which we see in our daily life, right? Like trains, buses, vehicles, birds flying in sky, raindrops, motion of people around us, so etc. So there are many more examples for this motion which we see in our daily life, right? Motion is simply defined as a body or an object is said to be in motion when its position is changing with time. That is what we have discussed here, right? Okay, the car position is changing from point A to B with respect to time. Okay, and this motion is always described with respect to the view of the observer. Okay, అంటే ఒక బాడీ మోషన్ అనేది ఎలా డిస్క్రైబ్ చేయొచ్చు, ఒక అబ్జర్వర్ పాయింట్ ఆఫ్ వ్యూ లోనే అది డిస్క్రైబ్ చేస్తాము. ఓకే, సో లెట్ us take a small example for that point. Okay, so first assume this is a road and a car is traveling on this road, okay, towards east. So this car contains a driver and a passenger, and assume a person is standing beside the road. Okay, let this person be A, the passenger be B and the driver be C. Now if you ask the person A that whether the car is in motion or is at rest, then what the person A would answer? He would definitely say that the car is in motion. So here rest position ante enti, we already discussed what is motion. Motion ante enti, movement of an object with respect to time is called as motion. Then what is rest position? Rest position ante nothing but the object will remain stationary. Okay, it will not move, it will be at rest, that is it will be stationary in its position. Okay, so the person A will answer that car is in motion. Now again if you ask that person A whether the persons who are sitting inside the car, that is passenger and driver, are in motion or at rest, then what he would answer? The person A would definitely answer that the persons who are sitting inside the car are also in motion along with the car. Why? Because the people sitting inside the car are also traveling along with the car, so they are also in motion. Okay, so if you ask a question to person B, that is passenger who is sitting inside the car, that the person A is at motion or at rest position, then what the B would answer? He would say that the person who is standing beside the road is definitely moving, he is in motion. And in which direction he is moving? He is moving towards west side. Okay, why? Because the car is moving towards east, the person who is observing the A person is assuming that A person is moving towards west side. Okay, now if you ask the B person again a question that the driver, that is the C person, is at rest position or in motion, then what the B person would answer? He would say that the C person is in rest position. Why? Because the C person is sitting in a seat and driving, that's it, he is not moving, right? He is stationary. So B person is saying that the driver or the C person is at rest position. Okay, so if you ask him again, what position you are you in a rest position or in a motion? Then he would say that I am also in a rest position because I am also sitting on a seat. I am not moving, right? So he would say that I am also in a rest position. So in his point of view, he is saying that he and the driver both are in rest position and car is moving and the person who is standing beside the road is moving. But in point of view of a person who is standing beside the road, he would say that car is moving and along with the car B and C persons are also moving, so they are also in motion and the person is at rest. So for this situation there is a simple example. Okay, when we are traveling in train, if we observe outside scenario from our window, what you will observe? The things which are there in that point, that is trees, buildings, which all we are seeing from the window, we feel that those things are moving and we are at rest, right? సో ఒక ట్రైన్ లో కూర్చున్నప్పుడు విండో నుంచి చూస్తున్నప్పుడు మనం ఏం అబ్జర్వ్ చేస్తాం? బయట ఉన్నవన్నీ వెనుక వైపుకి వెళ్తున్నాయని అనుకుంటాం. సో ట్రీస్ కనపడ్డా, బిల్డింగ్స్ కనబడ్డా అవన్నీ బ్యాక్ సైడ్ కి మూవ్ అవుతున్నాయి అని అనుకుంటాం. సో అక్కడ ఒక బిల్డింగ్ ఉందనుకోండి, అక్కడ ఒకరు నించొని ట్రైన్ ని అబ్జర్వ్ చేస్తే వాళ్ళు ఏమనుకుంటారు? ట్రైన్ ఏ మూవ్ అవుతుంది అనుకుంటారు. బట్ when we are sitting inside and we are observing them, we are assuming that they are in motion and they are moving backwards. Okay, so this is what happening here. So by this we can conclude that the motion of an object or a body is described with respect to the point of view of a observer. Next, motion can be described with help of few terms like distance, speed, displacement, velocity, average speed, acceleration, etc. Okay, so firstly we will see what is distance. Distance ante enti? Distance is nothing but the length of the path through which the object is traveling is called as distance. Okay, for this you can take an example like ఇదొక గ్రౌండ్ అనుకోండి. సో వీఆర్ స్టాండింగ్ ఎట్ అ పాయింట్ ఏ అండ్ ఇక్కడ నుంచి మనం ఒక బాల్ ని గాల్లోకి విసిరేద్దాం. విసిరేసినప్పుడు అది ఇలా వెళ్ళి ఇట్ విల్ ల్యాండ్ సమ్వేర్ హియర్. ఓకే, ఎట్ పాయింట్ బి. నౌ ఫ్రమ్ దిస్ వాట్ ఈస్ ద డిస్టెన్స్ దట్ బాల్ ట్రావెల్డ్? డెఫినెట్లీ దిస్ లైన్. ఓకే, ఇది బాల్ ట్రావెల్ చేసిన పాత్. సో దిస్ లెంత్ ఆఫ్ ది పాత్ ఈస్ కాల్డ్ యాజ్ distance. Okay, so this is the distance which the ball traveled. And ఇందులోనే డిస్ప్లేస్మెంట్ చెప్తాను. డిస్ప్లేస్మెంట్ అంటే ఏంటి? డిస్ప్లేస్మెంట్ ఈస్ షార్టెస్ట్ డిస్టెన్స్ కవర్డ్ బై ది ఆబ్జెక్ట్. ఓకే, సో హియర్ వాట్ ఈస్ ది షార్టెస్ట్ డిస్టెన్స్? దిస్ ఈస్ ది షార్టెస్ట్ డిస్టెన్స్, రైట్? Okay, so this shortest distance is displacement. Okay, so by this you have understood what is displacement and distance. Distance is nothing but the length through which the object travels. Displacement ante enti? Displacement is the shortest distance covered by the object in a specified direction or in a straight line. Okay, so we can take another example for this. If an object is at point A and it want to reach point B, then it has several paths. Okay, so there are 3 paths: path 1, path 2, path 3. Now if the object or let us say the object is car. Okay, if the car is traveling from point A to B through path 1, so what will be the distance in this case? It will be path 1, length of the path 1. Okay, so length of the path 1 will be the distance traveled by the car to reach B position from A. Okay, so if it traveled from path 2, then the distance will be the length of the path 2, right? So in this case what will be the displacement? Displacement ante shortest path, right? So what is the shortest distance or shortest path? This would be the shortest path or shortest distance to reach from point A to B, right? So this shortest path is called as displacement. Okay. So total displacement ni ela find cheyagalutam? Let us say this A position is initial position and B position is final position. Then delta x equal to xf minus xi ante final position minus initial position, we will get the total displacement of that particular object, or in this case car. Okay. So this is the meaning of distance and displacement. Next, let us see the differences between distance and displacement. First, it is the length through which the object travels, and displacement, it is the shortest distance covered by the object in a specified direction or in a straight line. These 2 points we have discussed just now. Okay. So it is denoted with letter D and displacement is denoted with letter S. Okay. Distance is a scalar quantity. Now, what is a scalar quantity? Scalar quantity ante to describe any physical situation, we use this scalar quantity and a vector quantity. So, this scalar quantity only gives us information about the magnitude of the object or a body. Okay. So, the scalar quantity only has a magnitude, but it don't have a direction. That is, it does not give us information about the direction. Okay. Whereas displacement is a vector quantity. Vector quantity ante it has both magnitude and direction. That is, vector quantity gives us information about both magnitude and direction of that particular object or a body which is in motion. Okay. So next, it has only magnitude but no direction in case of distance. Okay. Whereas displacement has both magnitude and the direction. Okay. Next, distance depends on the path travelled by the body. Yes, we have discussed this point just now in this previous example. Here, there are number of ways to travel from A to B, but the distance would be the path length which we choose to travel. Okay. Next, displacement depends on the initial and final velocity of the object, right? Here we have explained that, right? Next, distance is always greater than or equal to displacement. Okay, to understand this point and this point, 6th and 7th points, let us see a small example. Okay. So let us assume there is a path which have some readings like 0, 10, 20, 30, 40, 50 and 60 meters. Okay, these all are in meters. Okay, let us say an object is at point 0, that is, let us say this point as A. Okay, and this object has travelled from A point to till 60 meters. Let us say this point is O. Okay, or else we will assume that object as car. Okay, so the car has travelled from point A to O. So in this case, how you will find distance and displacement? First, we will find distance. So what is the distance that car has travelled throughout its journey? It is AO, right? So what is the distance? 60 meters, right? So again, what is displacement then? We will calculate displacement as delta x equal to xf minus xi. So what is the final position of that car? O point is the final position of that car, right? And what is the initial position of that car? A point is the initial position of that car. So where is the A point? It is 0. Where is the final point? Is 60 meters. So 60 minus 0. So how much you will get? 60 meters. Let us say this is case 1. Okay. Okay. Now let us take case 2. Okay. Let us say there is same path. It have same readings like 0, 10, 20, 30, 40, 50 and 60 meters. Okay. So the car has started from A point again. Okay. From this A point, it has travelled to 60 meters. That is O point. And again from 60 meters the car is traveling till, let us say, 30 meters. Okay, let us say this point as B. So how much the car has traveled? It have traveled A to B point, right? So what will be the distance in this case? It will be the total journey, the total path which the car has traveled, right? So what is the total path? AO plus OB, right? So what is AO? 60 meters. And what is OB? 30 meters. So what is the distance that car has traveled? It is 90 meters, right? So now we have to find the displacement. So what will be the displacement of that car in this case? Delta x equal to xf minus xi, right? So what is the initial position of that car? In this case it is A only, right? From this point only the car is starting, right? Then what is the final position of that car? It is B point, 30 meters minus, what is the initial position of that car? It is 0. So what is the displacement of that car? It is 30 meters. Okay. So this is case 2. Now let us assume another case, that is case 3. Okay. So in this case, let us say there is same path, okay, which have same readings like 0, 10, 20, 30, 40, 50 and 60. Okay. So again the car is starting from point A. It is traveling till O point. Again from O point it is traveling till A point. Okay. So the car has started its journey from A point and it have ended its journey at A point. Okay. So for this, how we will find the distance? What will be the distance of the car? It will be AO plus OA, right? So what is AO? 60 meters. And what is OA? 60 meters. So what will be the distance? It will be 120 meters. So the total distance which the car has travelled is 120 meters. Now displacement. Let us find the displacement. So delta x equal to xf minus xi, right? So the final position of the car is at point A, right? And what is the initial position of the car? The initial position of the car is also at point A. So here the final and initial positions are same. That is 0 minus 0. That is 0 meters. Okay. So the total displacement of car in this case is 0 meters. So what we have studied in this 6th point? We have studied that distance is always greater than or equal to displacement. Okay, let us see that point in this example. So in first case, distance is equal to displacement, right? So in case 2, what is happening? Distance is greater than displacement, right? In 6th point, what we have studied? Distance is always greater than or equal to displacement, right? In first case it is equal to displacement, in second case it is greater than displacement, right? And 7th point, in 7th point distance cannot be 0. So in this third case what is happening? Distance is not becoming 0, it cannot be 0, whereas displacement can be 0, right? In this case displacement is becoming 0, right? So distance is always greater than or equal to displacement, whereas displacement is always less than or equal to distance. Okay, next 7th point, distance cannot be 0, whereas displacement can be 0. Okay, so we have seen case 1 and case 2 for 6th point and case 3 for 7th point. Okay, the SI units of distance and displacement is meters and this is denoted with letter M. So that's all for today's session. In next video we will cover other few topics of this chapter, and please like, share and subscribe to my channel, and please support my channel. Let us meet in another amazing video.